Hi, this project is based on customer revenue generation. Basically, we are trying to find if a customer will generate revenue or not for us. So let's move on to the next slide. So what is customer revenue? Customers are the backbone of any modern industry or any business for that. They can lead your business to greater heights if you know how to leverage their participation and interest. Now, customers can invest in your services or maybe products at various stages for their customer journey. And that is what we know or call as customer revenue. Now, these revenue can be actually in the form of one-time sales or recurring revenue. Like for Netflix, for Netflix subscription, you can say that the type of revenue is actually a recurring revenue. Or let's say if you're buying a car and you're having your down payment for once, so it can be said that it is a one-time sale. So while we are discussing, actually the data set for this project is based on metadata from a shopping site. This metadata was actually stored and retrieved from that site itself, and that is what we will be using for our prediction also. Moving forward, so this is the detail of the project. Now the project is divided into three parts. The first is building a deep learning model to predict customer purchase completion. The second is building a web application that is based on Django framework. And the last is deploying that Django framework application, or I would say the Django framework web application on Heroku. Now the first part is building a deep learning model. So we start off with building deep learning model, a sequential model with 3 hidden layers, and train that model using our customer metadata, or I would say our dataset. Next is building a web application model. So we will be using Django, and we mount the model that we build in the first part into the second part, that is on our Django web application. Lastly, we deploy this application or web application onto Heroku using GitHub. So now let's move forward to the first part, that is where we are building our deep learning model. Now we start off with the first part of the project, that is building a deep learning model. This will actually be a very simple sequential model with only dense hidden layers, meaning that for our layers we will be only using dense layers with maybe different activation functions. Now you can see that the first thing that I have done is actually mount my drive, or where I am storing the data set, to the Google Collaboratory. The next thing you can see that is I am actually importing my necessary libraries. And you can see that the NumPy library, Pandas library, and both the Seaborn and Matplotlib for visualization. The next thing you can see that for deep learning, I'm using the TensorFlow package and calling out sequential and dense. So our sequential model and dense layer. So I've actually provided the link for the dataset here, and you can refer to the site for more understanding about the data. So you can see that I've commented out the link for the dataset, and the next thing I'm doing is actually calling out my data from the drive. So after writing the variable name dot head function, you can see that the first 5 data points are being shown here, and a lot of columns are present, some having integer values, some having float values, and some are categorical type data. So before we move forward, actually let me clear out some of the terms from the data set so that it becomes a little easy to understand the data first. So the first term I would be telling you about is bounce rate. You can see that the bounce rate is present here. Okay, so it actually represents the percentage of visitors who enter the site and then leave rather than continuing to view other pages on the site itself. So that is the first that I wanted to talk to you about, that is bounce rates. So this is a very important, I would say, column or data point, because it is telling me that if there was a visitor, then did he stay on the site or did he directly, before moving to my goal, I would say, page, he went on to some other site. See, your site might have a lot of pages, okay, showing different kind of information for different products or services. But your goal page, I would say, or where you want the visitor to visit actually, would be the page where actually the payment is being done, or you are actually asking the visitor to buy anything. So that is what I'm trying to say by goal page. And the bounce rate is telling me that the visitor entered the site and then left rather than continuing to view other pages. So the next is actually that I'm talking about would be exit rates. Now exit rates refer to the number of times visitors have left a site from a single page. Meaning, let's say that a visitor came onto any one of the pages from the site, and rather than, I would say, going on to another page exploring that site itself, the visitor saw the first page and left from there itself only. Now the next I'm going to talk about is page values. Now this value actually intends to give you an idea of which page in your site contributes more to your site's revenue. Meaning that I talked about our goal page. If a page is actually helping visitor to go forward to the goal page, then the page value would be high. If the page is not contributing at all for the visitor to go to the goal page, then the value would be 0. I would be using the describe function so you can see that what the max value and the min value for page values is, and the rest are understandable. If there are some columns that you aren't able to understand, then just visit the link itself or search the term itself. You would get to know more about the data in that way also. Now, now from this, let me just clear that out, that our target column is revenue, meaning a boolean representing whether or not the user completes the purchase. So it might happen that the visitor actually did reach the goal page, but maybe he didn't purchase anything. So then again, that would be a false for us, because the final goal point was for the visitor to actually buy something from us, which he didn't or she didn't. So with that in mind, the revenue is categorized as false or true. And that is what our target variable is. So next you can see that I am using the describe function, and for all the integer or float type data, you can see the count just telling me that there are 12,000 data points, and the mean for each column, the minimum, standard deviation, this is standard deviation, and these are actually quartiles. Okay, so the quartiles for each column. Now you can see that for column administrative, the max value is 27, the min value is 0. But for administrative duration, the second column, I have a min value of 0, but max value of 3398.75. So you can see that the ranges are actually very, I would say, far away from each other. A value of 27 is very small as compared to 3398. So if you want, before moving forward, you can actually normalize this column so that the ranges are actually comparable for both the columns, or you can standardize the whole of the data itself, or maybe sub part of the data, so that the ranges come in a closer and more appropriate way, so that this maybe changes to only 33 or 34 rather than being at 3000. Similarly, you can do that for other columns also. But the reason why I actually wanted to show this was that you can actually gain statistical knowledge about your data without much of coding or without actually maybe manipulating the data, just using the describe function itself. So the next thing is, yeah, dot shape. So dot shape is basically giving me the cardinality of the data set, telling me that there are 18 columns and 12,330 data points. With this, we come forward and look for null values in the data. So dot is null dot sum is giving me the number of null values for each of the column. Now this is pretty much clean data as all the values are present for all the columns. There is no null value. It might happen that there might be some outliers in your data, and you might want to figure them out. So what you can do is basically take one column and see what its mean is and what its maximum value is. From that itself, you can get a rough idea, not a generalized idea, but only a rough idea if the dataset is having outliers or not. Or what you can do is use matplotlib or cbond to build graphs for the columns you might think that have outliers. I haven't done that, assuming that there might not be any outliers. So I'm simply moving forward to look at the correlations for all the data points, or I would say for all the columns. Yeah, that is better. So I'm using my matplotlib to size out the figure and using my cbond, and from that heat map function, which is building me a map for each of the columns and their correlation. So you can see that the pandas variable where my data set is stored is having dot core, which is giving me the correlation, and I'm sending that as my first parameter to my cbond heat map function. So you can see that a lot of values are present and there's a bar shown for 1 to reaching -3, -4 maybe. Okay, maybe -2, -3. So what this tells me is basically, yeah, let me just talk about correlation first, because it can happen that some might not understand what correlation is. So correlation is basically a metric that is telling you that for two columns, how much related they are or how much dependent they are on each other. Okay, so let's say there is a column A and column B having a correlation of 0.8. Okay, positive 0.8. That tells me that A and B are very much directly related to each other. Meaning, if a value in A changes and increases, it will happen that the value in B corresponding to A will also increase, and by the ratio of 0.8. So what you can do is understand if two columns are too much correlated or related to each other. They can be directly related, they can be inversely related, but the point is to erase out or drop one of the two columns if both the columns are highly correlated. This is because a column that is very much correlated to another column will not signify much or will not be able to express much to the model and won't help the model in generalizing over the data itself. And when I say generalize, meaning to understand the patterns in the data. So for that, we are finding out if there are actually two columns that are highly correlated, and if there are, that means we are going to drop one of them. Another thing you can do is, actually this is not for categorical target variables where actually there are two classes or multiple classes. But for, uh, I would say, but for data set where you're actually predicting a number, where actually you're using regressor classes, maybe linear regressor or random forest regressor, what you can do is also include the target class or the target column inside the correlation graph and see if a column is very much related or very much correlated to your target variable. That means that the column is determining or is dominating at determining the value for your target class. Now it might not be much clear from just me telling you about it. Having a practical example would be much better. So yeah, I can't show you for the regressor, but I can show you for classes, or I would say categorical, like true, false, determining two classes or multiple classes. Okay, so first we can see that for administrative, you can see that there's the value of 1 because it is highly correlated with itself, obviously. And then there's the value of 0.6, 0.38, and so on. Similarly, for all the, you can say, integer or float columns. But what I want to actually show you is that values like 0.86 are high, and you can see that product related is actually very much directly correlated to product related duration. So we can remove one of them so that our model, when taking this data, is able to generalize over the data well. And I'm not talking only about positive values like 0.86 or 0.91. Even negative values, if they are very high or very low, closer to -1, you have to remove them also. Though it actually depends on person to person. One might say even 0.6 is a very high value, I would remove. But some might say, yeah, let's consider 0.6 as it is. Only remove the 0.86 and 0.91 values. So with this in mind, you can see that later on I'm dropping administrative, informational, and product related duration columns. So now we are going for the categorical data. Actually, I really like categorical data because they are hidden gems. If you're able to extract them, then you can find even more information from the data itself, and it can help the model because now the model doesn't have to, computationally work even more to find the hidden values. It can simply use all the data that you have extracted and is able to perform even better. And with that, we're going for finding categorical columns first. So first is product related, and you can see that it has a length of 311, meaning that from 12,000, more than 12,000 data points, only 311 unique values are present inside the product related. So, and you can see that it ranges from 1 to 399. Okay, okay, it not actually ranges from 1 to 399. You can see a 409 present here. Okay, but the length is 311. Basically, 311 unique values are present inside product related column. So how we are actually looking at this data is using the dot, basically value count function, that is telling me that for this data or for this series, it is finding me all the unique values and how many times each has occurred inside the data. So the value 1 has occurred 622 times inside the product related column. Simply I'm doing this for month, operating system, visitor type, browser, region, and all that. So after that, I'm able to understand that some of them are categorical data. I'm extracting information. Basically, I'm handling categorical data to build even more data so that I can put that directly into the model and it is able to understand the patterns itself. So the first thing I am using is get dummies. That is basically extracting the information. And you can see that I have sent the visitor type column as the parameter or as the parameter. Now the next thing you can see is I'm using the concat function to join both the shop, that is my variable for dataset, and the visitor, that is the new data that I have made from get dummies. And you can see that, yeah, you can see that we only had till revenue in our original data set, and now three more columns are present telling me new visitor, other, and returning type. So these are the categories that were present in the visitor type column, and I've now extracted each one. And you can see that there's two zeros and then a one. This is telling me or defining that for the first data point, the visitor was actually a returning visitor. So 1 is present here and 0 for both the other categories. Now I'm going forward and segregating the target variable from my data set, which is input as y. And now you can see that in the data set, the weekend and revenue both are considered as false or true. Only two values determined by false and true. So for the weekend, what I'm doing is actually converting it into 1 and 0. So false for 0 and true is converted to 1. And how I'm doing this is using my as type function over the weekend. So I'm building a new column and having ones and zeros as its data points. So now you can see that after using dot shape, the number of columns have turned to 15. Now remember, we started off with 18 columns, and even after extracting the categorical data type, we have come up with only 15 columns. Now I won't say only 15, but yeah, we have come down from 18 to 15. So next thing you can see is that we have our sequential model. So I've instantiated it, okay, and have now added dense layers with activation function as ReLU. And for my last output layer, I would say I have my dense layer with activation function as softmax and units 2 telling me that there are two classes. So after compiling my model, you can see that, okay, yeah. So basically, this is a very brief about what each part of this code is doing. And you can see that just about, like I said, for our two classes that are true or false, we have our soft activation function and 2 units in our dense layer. Also, while compiling the model, we are using Adam optimizer along with accuracy as metric to maximize the same and minimize our defined loss, that is categorical or sparse categorical cross entropy with each epoch. Now, let me just define one thing, that categorical cross entropy is used mostly when there are classes, or I would say there are more than 3 classes that are to be predicted. Let's say there are classes A, B, C, D, okay, not just a true and false. That's when categorical cross entropy is used. Or for only when there's a two class prediction, we mostly use binary cross entropy or maybe sparse categorical cross entropy for sparse data. Now you can see that I've used the fit function to now train the model. That gives me with 83, 84, yeah, 83, 84 percentile of accuracy. And even the training accuracy reaches 90 or 91 at max. So the model is not overfitting. And I can live with this accuracy for the data set. Though if you want, you can increase the accuracy by using different kinds of layers rather than just using dense layer and activation functions as ReLU. And that is up to you. But for this project, I have just used those only. So after I have built the model and trained the model, I'm just saving the model so that I can use that specific model inside my Django web application itself. Okay. And for that, I've used this. So with this, we come at the last part for the first part of the course. And now we will be jumping on to the second part, that is building our web application using Django framework. Now, this is the second part of the course where we are building our web application using the Django framework. Now, before we move on to the code part and understand how the code is working, there are some steps to follow, and let's see those. So the first step is just directly building a project directory where you can store this code itself. Then before running any command or setting up, just build an environment for this project itself. Now once you once you build an environment, run this command that I'm typing, or I would say that go inside the my site directory first. Okay, like I have. So my project directory was shopping intention, and then I'm inside my site directory, and then run the command pip install r requirements.txt. So what this does is basically it tells the environment that all of these dependencies, yeah, all of these packages are to be downloaded and installed so that this code can access those packages or maybe modules and use them in the code. So this is very important. And what another thing this does is that it tells you exactly what or exactly which package version has to be installed. So once you do this, your environment will be set up and you can use the code or run the code. So now inside the my site directory itself, just run the command python manage.py migrate. Now this is specific to Django, and it is what it does is basically it sets up the database that is required by your Django application itself. Now Django already gives you a set of, I would say, pre-built tables which can be used or which can be modified later on. So for implementation of those pre-built, okay, for those pre-built tables, I would say this command here is run. So once you run this, you would see that a db.sqlite3 file has been created, meaning that the table is now created or the tables are now created. So once you do that, all you have to do for last is python manage.py run server. So what this does is basically tells the code that yeah, everything is set up and you can run the code or the web application locally, or I would say deploy the application locally. So last of this part, yeah, this part is basically telling that how did I build a project and how did I build an app. If you can look here, so see, this my site was actually a project. So this command is what I have to run so that I can build the project itself. The name of the project for me was my site. And now what you do is go inside again the my site directory, and you can say that I went inside here and ran the command python manage.py start app and then again name of the app. So the name of the app I gave was polls. So you can see that first project was built, okay, and project has this all of these my site URL settings and stuff, and you can see that polls, that was my app, has all of these, not exactly all of these, since some of the folders or files was what I made. But you can see that pre-built stuff has been provided to you by Django itself. So this is what I used to build the base of the app itself. Now I can just simply modify and add according to my wishes. So you can see that views, which is inside my app itself, is where we are holding the data, or we are holding the code where it will be rendering all our pages, handling all the data that comes through our page, and returning the data also. So you can see that the most important part of the Django framework or of the Django web application is what we are doing in views. So you can see that. Yeah, let me just open the HTML page also so it makes it a little clear. So yeah, you can see there's a HTML page. Now it is having a form in it. Okay. My God. Yeah. Oh my God. It did it hang? Yeah, I think it hanged. Yeah. So you can see that there's a form and it has some of the inputs that it is taking. Okay, a lot of inputs I would say, and then at last it is asking you to submit this. Okay, so once you submit, all of that data comes through to the views, and now I'm storing them inside my variables that I have defined. And once I've stored them in my variables, I'm inputting all of those into a data frame that I've created here. So you can see that the data frame has been created, and then the values are being input into the data frame. And then you can see that there's a load model, which means I'm loading the deep learning model that I built in the first part in the collab, and now calling that model and using the predict function to predict the outcome for the data that I've input from my HTML page, home page. So you can see that I'm using the model, I'm using the prediction function, and last I'm storing the result. Now you can see that there is a return function which is returning a render function itself. So basically this render is actually rendering the page, and with itself it is also sending the data from my backend to the front end using context that I have defined here. So you can see that the result I'm sending back again to the front end, and then it goes here, and then the value is shown after the completion of prediction by my model itself. So you can see that this is what I have done. But another thing that I want to highlight here is that there is a function named first having a parameter request. And then you can see that if I go down, there's a function named finding type having a just simple parameter x taking back integer values. So what's the difference between these two? Because there is a difference. And you can see that this function is actually rendering a HTML page. So a function that is rendering an HTML page is specific to that page itself. And all of that data that comes and goes through the front end is handled by this function only. Now the second function that I built is just a helper function. Since it is not taking request as its parameter, that means that this function is not handling any of the pages, not rendering any of the pages, just used to manipulate data only. So this is the part where most of the work done by the web application at the back end is happening, and the front end, just as I showed, is taking values and returning a result or showing the result after completion of prediction. So yeah, this is the part where I would say that Django Web Framework is helping us develop a web application and with much ease. Sorry. yeah, with much ease, because all of these might not be okay. So all of these, like the views, the admin, apps, URLs, are predefined or pre-made, and I just have to modify or add code into them. And the web application or the Django itself sets, and not only sets, but also keeps a check that there is no vulnerability in the code itself. And for that, let me show you this settings.py file. Now this settings is actually present in my site directory. Actually, my site directory inside my site directory. Okay, so settings, you can see that there's this here. You can look through the docs that are provided by the Django. And before I move forward, just see that the installed apps, one app was what I made, but there's pre-built apps also. So you can see that static files, there's an app for static files for messages, sessions, auth, admin. This is for basically login and log out. If you're building a login and log out application, or having an application which has login and log out feature, so this is what it used for. Again, static files, for files that are like HTML, CSS, handling of all those files is done by this, or storing where is done by this. Similarly, you can see that there is a middleware function. So this is where most of the middlewares are added or set, so that Django is aware that yeah, all of these middlewares are to be used for security so that there's no security mishap or there's no vulnerability in the code itself. Now, before we go to the third part, let me just tell you that even after you have built the web application, you have to make some changes and add some files before you can go to production. So the files that you have to add are first proc file, runtime, and there's a requirement.txt file, which I haven't added till now, but I would before going to the third part. And you can see that the last thing is, yeah. So while you have predefined settings, predefined views given to you by Django, you still have to make some changes so that you can go to production. The first change is you have to add this static root. So it is basically telling you that, yeah, once this code goes to production, you have to collect all the static files present in the code and build a static files directory, and all of that static files has to be input inside this static files directory itself. Okay, this looks a little confusing. So if you think that you haven't grasped the notion of why we are building static files or what is happening, you can just go to the doc present here, and it might make clear some things that here you might be thinking, yeah, yeah, this is like a little hard to understand. So if you go back up, you can see there's a debug and there's a allowed host feature also. Not exactly features, but variables that are storing some values. Now it is already said that security warnings don't run with debug turned on in production. So debug is actually set to true, but you have to set it to false before going to production. Okay. And another thing is allowed host. Now this is basically telling that your code or web application, it can run on which host or it can run on which DNS. So you have to set that up. Now, if you want to run this code locally, you have to set this. And if you have to run this on some server, then you have to run this or set this up. I will tell you where this actually came from, but that would be in the third part. With this, I would like to tell you that the second part is over, and now you understand that where you have to make the changes, where you have to actually add on the code, where you have to actually create new files and then add on the code so that your web application is set and is working also. So now the second part is over and we will go to the third part, which is probably the last part, that is Heroku and deploying this web application on Heroku itself. This is the third part of the course where we will be deploying our web application that is made on Django on Heroku. So before we start with Heroku, we have to use some files which are like commands for Heroku to understand. And those files are runtime.txt and procfile. So runtime.txt is basically just telling Heroku which language or base it is to use on the server when setup of the code is happening. Now the second file, which is procfile, has a little more depth in it. So procfile is a mechanism for declaring what commands are to be run by your application in the Heroku platform itself. The commands that are specified in the last part, or I would say in the second part of the course, like run server or migrate, or I would say that Python manage.py run server or Python manage.py migrate. So there are even more commands that have to be run if the code has to be set up on production or inside a server itself. The commands that I specified were those, and there are many more commands also, just like I said. And those commands are actually executed in Heroku's server using the procfile. And this G unicorn is basically asking the WSGI file to set this up and give a log file or give a log of all the processes that are happening on the server. So with this, we have already defined all the new files that have to be created for the production. And let me just, I think I've already specified that you have to set the debug as false and this also. So let me tell you where this link actually came from or where this URL actually came from. So once you go to your Heroku platform, so you can see that first of all, you would be redirected to your dashboard. Okay, this is actually inside one of your apps. So first you would have to create an app itself. Now you can see that there's an app, and for that app there's this link present here. Okay, so once we go, and you can see that I can click on this app. So if I click on this app, you can see that there's a link present here. So if you just copy this link and go back to your code, so you can set that up from here. So once you have done this and set up, you can push this code to GitHub, from where we will be actually hosting, or I would say helping in hosting the code itself. So yeah, now once you have done this, or I should go back and say that there's this your dashboard. Okay, you can just click on new, and from here you can create your new app. Since I've already created an app itself, so I have come inside the app and you can see some of the options given here. So first go to settings. Inside settings, you can see there's a build pack. So click on add build pack and choose Python. Now you have chosen Python. Since I've already done this, it is giving me that yeah, Heroku Python is, this build pack has been already set up for this app. Let's go to deploy. Inside deploy, choose the GitHub. Now it would ask you to log in. Okay, once you have logged in, it would say that here it is connected to your repository, sorry, your account. Since mine is sitp.278, so it is connected. Then it would give you an option of connecting any one of your repository to this app. So I have already again done that. So it is showing me customer shopping revenue. Repository is connected. Once you have done that, go to the manual deploys and choose the branch which has the code. Since mine is master, I chose master, and once I click on this deploy, so then it would deploy my code itself. Since I've already deployed it, yeah, let me just redeploy it. So you can see that it takes a little time. And if there are large dependencies, since we are using TensorFlow, which has a very large package, it would take even more time to set up the environment and set up the code on the server. So you can see that it has now started using the Heroku Python build pack. And through runtime.txt, it is now setting up that yeah, Python and this version has to be used. So now you can see that it has installed the Python 3.7.10 version, and now it's starting to install all of the dependencies or packages for the environment to set up. And this is also going to take a lot of time, since each and every package is going to be installed, first downloaded, then installed. And after it has done that, it would go and start for the collect static, meaning now all the static files are going to be first of all aggregated and then set into the static files directory that you can see here, that it has 132 static files copied from somewhere to my statics files directory. Then it would compress the files because it is one of the processes that the Heroku itself has defined, I would say not defined, but set up for itself when taking all of the data from my temporary folders to the actual server inside Heroku itself. So all of that is now transferred, and you can see that after compressing, it has shown me that 306 MB of file size, or I would say all of the files combined, now are going to be shifted to your server. And since the slug size is greater than 300, it is telling me that it might affect the boot time. Basically telling me that it would take even more time again to deploy the code. So you again have to wait for it to deploy. And once the code actually has been deployed, you would be able to see that a deploy to Heroku will have a tick mark here, and then a box would be shown where it would be written view, and clicking on it you can go to the app or you can go to the site that you have now deployed. So as you can see, now view function has been so you can see that the app has now started to run on the server also, or the web application has started to run on the server also. And once you type in any product, let's say that with some duration 2 to 50 and then a value of 0.1, again 0.1, value of 33, value of 0.56, let's say. Yeah, UC browser, although I don't think many people actually use UC browser, but still. And let's say I'm a new visitor and it is not a weekend. So you can see that now it is showing the customer generated revenue, and it is true. So with that, we have now completed this course this project where the last part was deploying on Heroku, which we have done now.